Hi, I'm Dr Mark Donohoe. Join us for our new podcast series, FXomics. We'll be exploring the new technologies of integrative medicine, including genomics, metabolomics, the microbiome, and many more fields that are transforming healthcare. We're focusing on how they apply to practitioners and how we can incorporate them into our patient care. We aim to make these exciting and sometimes challenging fields relevant to you and your practice. Search for FXomics on your favourite podcast platform, and we look forward to your company.
This is FX Medicine. I'm Andrew Whitfield Cook. Joining us again in the studio today is Dr Mark Donohoe for part 3 of Evolutionary Medicine, Depression, Anxiety, Sleep and Neurodiversity. Mark earned his medical degree from Sydney Uni in 1980. He worked around the Central Coast, honing his medical skills, and this is where his interest in integrative medicine sparked, because his patients just weren't fitting into the boxes of diagnoses and treatments which were drummed into him in medical school. Mark is considered one of the fathers of integrative medicine in Australia, and he's been a vanguard for patient health throughout his whole career. Welcome back to FX Medicine, Mark.
Good to be back for part 3.
It's like a saga.
It is. But look, you know why it's a saga?
We've evolved.
Yeah, very good. It's a saga because it does fit with kind of natural healthcare, the concept of nature, environment. Why are we who we are? Why do we behave who we are? You know, that whole story is the why of healthcare. What does medicine do? My profession basically does the what, the name, the drug, the treatment. It's proximate. It's all very, scientific. However, it never asks that question why, and we don't go back deeply enough to change people, to change their health. And evolutionary medicine provides that brilliant way of saying, why would this even be here? And if we look back through evolutionary history, is there an answer that would be better?
Yeah. And this is what I love about your way of thinking, is that it doesn't just judge something. It says, what could there possibly be a mechanism there that had a function for us? Even illness, stops you from walking around while you're having that infection so you can heal.
That's right.
So let's get into it. Depression, a huge scourge of our modern day society. More and more stresses are placed on every individual, even from a young age now.
Yes.
What's the function of that?
Oh, you would start with the easy one. Depression looks to have no function. However, there are many ways of thinking about evolutionary medicine. Not all of them are, what is it made depression advantageous? Some of them are, what changed in our environment that has led to one adaptive response turning up somewhere else? And in depression, the critical point is the word inflammation. What do we suffer when we have the flu? Pretty well every one of us suffers depression, but we don't call it depression. Why don't we call it depression? Because in a week's time we know we're going to be out of it, we're going to get back to life, and inflammation is going to ease itself up.
We just call it sickness syndrome, or, in the case of men, man flu, which is a cold.
Yes, I know. That gives us an excuse to get off work. But depression in the short term is a symptom. And the thing that keeps bugging me in this world is we have now called a symptom a disease because there is a drug armamentarium which is suitable to fiddling around with it and making profits from what is a symptom. People keep making, I think, a basic mistake. The why of depression often leads to answers which are way better than just the what of depression. So sometimes it's easy. You've lost a partner, a child's lost a parent. Depression is an absolutely normal response to the stress of that loss and should be left alone. However, we now have rules in medicine which say if it goes more than 6 weeks, if it goes more than 12 weeks, then that's the time to intervene with drug therapy. Right at the moment, for bereavement, we're talking about 2 weeks as the time period to let a person get over the death of a loved one before we intervene with drugs. And
2 weeks?
2 weeks is the current distance that you're allowed to go, yeah. No, believe me, the movement for antidepressants should be that they will be preceding the death of a loved one before too long. In other words, that we will take active, barriers against depression.
Just in case you felt depressed afterwards.
And so this goes back to the people who believe that Prozac should have been put in the water supply many years ago, that it was an essential nutrient that our bodies lacked. So there is one form of depression which talking to a person uncovers the causes for. There's not much doubt about it. It's a reasonable thing for a human being who's a social being to feel low with the loss of someone or something that is dear to them. There's an entirely different area of depression which is related to inflammation. Why is that important? Because depression can be seen as depression only if the person describes it as depression. Otherwise, it's sleepiness. It's the signs and symptoms of depression, which are entirely allowable when we have an absolute, say an infection or a flu, for example. What's risen by a factor of 3 to 5-fold in the last 25 years? Autoimmune disorders. We have now a background of persistent inflammation in a high proportion of the population, 4 to 1 in favour of females. Autoimmunity 4 times more common in females in total than they are in males. Who do we treat as depressed? Females primarily get the majority of the antidepressants. Well over 60%, maybe up to 75% of all scripts written are for females. We failed to match this evolutionary process of a person going quiet, the body turning down all other responses, sacrificing and getting you into a stable state of inertia sufficient for you to get over an infection. Now we have different battles which are persistent infection or persistent inflammation of autoimmunity that does cause depression as a symptom, but we're seeing the depression as if it's a disorder, as if it drives the inflammation rather than inflammation driving the depression.
Can I ask a question about measurement of low-grade inflammation? When we're talking about, let's say, an autoimmune disease, Crohn's or something like that, we'll go CRP. We'll go TNF-alpha. If we're talking about an active infection, we might measure interleukin-1b. But what's the baseline that we want to achieve for resolution of these inflammatory conditions?
Well, that's a very good question.
And, the second part of it is, how would one measure the quote-unquote low-grade inflammation, chronic inflammation, runaway inflammation?
What we have is excellent measures of acute inflammatory processes. We can measure C-reactive protein. We used to measure the erythrocyte sedimentation rate. Just a simple thing, put a column there, see how quickly the cells crash down, and the more quickly those cells came out of the suspension and precipitated, the higher the level of inflammation in the body. Great for acute inflammation. People get a flu or a cold, ESR and C-reactive protein go up in the 30s, 40s, 100 range very, very quickly. People with very aggressive autoimmune disease, say active rheumatoid arthritis or active lupus, also go up to very high levels. The damage and the inflammation being caused is high. But those markers are markers of acute infection and acute inflammation. Why is that important? Because in medicine we have very good tools for fixing those things. When the body gets into a stable state of low-level inflammation, or when it affects the gut and the gut via the vagus nerve with the brain, where you get neuroinflammation and low-grade gut inflammation, those markers disappear. And we look and look and look for other markers. The person has all the signs of inflammation, the aches and pains, the joint pain, the rest of it, but there is no redness and swelling. If you've got redness and swelling, you've normally got a C-reactive protein and an ESR that you can rely on. If you've got the other type of adapted low-grade inflammation on the gut wall or the gut affecting the brain, the neuroinflammation of the brain, you do not see those markers, and it makes it really, really hard. What we can do, and what we're doing more, is looking at autoimmune markers. What is the body fighting against? And so the evidence for the rise in autoimmunity has a bit to do with the sophistication of finding how the body picks that fight, where it's going to war with itself. And so we are looking more now at maybe cytokine responses. I've seen a person just yesterday where there was no evidence with their fatigue syndrome of any chronic inflammation on any of the acute measures, but the cytokines were off the scale high. And
what sort of cytokines?
The
IL-17, 23?
Yeah, no, the IL-1. Funnily enough, this person also had all the all the anti-inflammatory cytokines equally high. So there was a body at war with the body trying to put out the fire at the same time. And that's what makes it so really difficult to get this. When the body does go to war with itself, triggered by whatever that, antigenic exposure is, or by persistent infection, it turns on the cytokines which are anti-inflammatory as well. In that state, you're in a kind of flu-like state, but you don't look too bad. You actually look fairly well.
Yeah.
And people come along with these conditions now, and the first pass through the medical community is nothing there. Don't worry about it. You must be depressed. Instead of seeing depression as one of the signs of inflammation, we're seeing it as if it causes all symptoms that we cannot explain in medicine. We put people on antidepressants and often they will complain less because the feeling of depression can be brought under control and it does nothing to the inflammatory process or the illness or the weakness or the fatigue that goes along with it. So that it is just a description of probably 50% of all depression, where there is no very obvious cause, proximate cause, changing jobs, death of a spouse, death of a child, something like that, where there is no obvious cause. What we doctors should be doing is taking the evolutionary approach and saying depression is a symptom of inflammation. Let's look for where that inflammation is.
Yeah.
And now we're getting more sophisticated brain imagery. We're now seeing that the nuclear medicine group, the functional MRIs, they're all saying, wow, look at this. The brain is in a neuroinflammatory state. Where does that come from? No invader of the brain. And it turns right back down to the vagus nerve and the stimulation coming from the gut. So gut, vagus nerve, brain is a very important axis of inflammation which causes depression very, very directly. What's going on in the brain will make a person feel depressed. Give that person something to settle the inflammation, the depression settles. Much, much better than it does with antidepressants.
Neuroimaging is still, quite in its infancy, not just with acceptance, but also costing. What about cheaper tests, like, for instance, say, immunoglobulin response? We've got IgE, for instance. We know that there's an allergic response going on. From an evolutionary point of view, it was to protect us against parasites.
Yes.
They're no longer there because we have the Dettol generation, so it's wanting to trigger. But when I say that word wanting to trigger, something is required to cause that to happen.
Yeah.
What about the other immunoglobulins? Do we find a heightened response with certain infections?
We do, but just to come back to IgE, it's a good evolutionary one because you're quite right. Immunoglobulin E, the mast cell type response, had a protective effect. And an immune system whose job it was to look after parasites, that is fully armed and ready to go and doesn't find parasites, looks in areas that it should leave alone. Dust mites are not terribly invasive to a human being, pollens and grasses aren't, but it just turns out that as the immune response amplifies its search for the missing parasites, it can, in a certain group of people, catch hold of unrelated molecules, have nothing to do with risk to health, but become a risk to health because the body has not been otherwise occupied. And it's a really good example. This is part of, as you would know, the hygiene hypothesis as well, that we need our enemies in order to keep our defences active, targeted, and not go wandering around looking for battles that are unnecessary. In fact, it's a very important part of what's now being seen as an autoimmune escalation, that we've been so good at sterilising our world. We do not stop the immune system looking for the problems. We just give it different targets after a while. And what have we done? We have also, in that same time period, we've changed our diet so that when it goes looking for something, it often finds it on the gastrointestinal wall. The parasites, the bugs, the blastocystis and Giardia and things that would, good decent fights, wash you out, clear out the entire gut very, very dramatically. If you survived it, you got out the other side and you had a clean gut and your body had done its job. Now we've basically sterilised our water and sterilised our gut to some extent. So new things come along, they interest our immune response. And if we are set for that antiparasitic response, it can become allergy, and mast cell activation on the gut is now a very, very big thing. When you release histamine on a gut wall in response to innocuous foods or bugs that are really not a threat to health at all, then your health goes down with that chronic low-grade inflammation. You've got nothing better to do. The immune system, we can't make a case for going and infecting people intentionally, but we can make a case for kids getting into the dirt, playing, doing things, having the normal cuts and bruises. We've become so protective of our precious little creatures that we forget that there's a downside to being precious, and that is an immune response, untested in the real world, goes looking for things to fight, and those things then become ourselves or the normal flora of our body.
And get a pet as well.
Yeah, get a pet. Get a Digby.
A dog.
Well,
it's been shown, just for our listeners to explain that comment, it's been shown that if you have particularly a pet dog, that they share their microbiota with you. We've been entranced into saying the word microbiome because it rolls off the tongue easier, but it's bugs. These are live bugs. And we share them with intimate partners. And I don't mean that in a weird way.
Yes, okay, we won't go there.
But people that we're close to, animals that we're close to, but particularly dogs, it seems.
Yeah, I think the answer there that was not that we get dogs bugs, but that the dogs have something to do, by their habits or something, of making the microbial environments of all their humans fairly similar, that there is an ability to share what's good as well as what's bad, and for there to be a kind of communal, familial, community type of response. We never lived in houses of 3 people previously with one dog. So I think the biology of it was we made friends with these dogs a couple of 100,000 years ago, and those dogs have been cohabitants with us, and we've adapted to each other along the way. They don't get sick with us. They do something, apart from those big eyes that make you cry when you see them. They do something for us, that's right, that helps our health. But that's a co-evolutionary process even in itself, that dogs at the beginning were wolves. We didn't have all that many wolves around, especially when the babies were out there, and you had to be very careful of the dogs. But the infantilized ones do something positive in their home environment.
I can't remember how many thousands of years ago. There was a recent article that said that it was a lot earlier than what was previously proposed, at like 30,000. Now I think that's 50,000 or something like that.
It swings backwards and forwards. But I mean, there was one point where it was 150,000 years ago, and I think that one was a misreading.
Right.
But anyway, evolutionary processes are slow usually, and we adapt slowly. However, our last 100, 200, 300 years has been environmentally rapid at a rate that evolution does not manage, and we are still cave people from a long time past trying to live in a world which is not a cave any longer.
Just to wrap up that sort of allergy symptom conversation, from an evolutionary perspective, the function of itching when you have an allergic response, itchy eyes, or let's say an eczema, I pondered on this, and is this an archaic, primitive attempt to try and rid one's body of a noxious agent, to make your body form exudate to get rid of a noxious agent?
Goodness. You ask difficult questions. I don't think anyone's ever asked that question before. Itching of the skin and eczema in particular are normally histamine responses on the gut. So
on the gut.
And that's a thing worth remembering. When kids get eczema, around 80 to 85% of those children have allergic responses to something that is being eaten. And now, just recently we've had Westmead Hospital, the gastroenterologists and the allergists saying if you use the probiotics in late pregnancy, if you stop treating eczema as though it's a skin condition and treat it as though it's a gut condition, that the quality of care and the reduction of itching and eczema goes up dramatically. So the gastrointestinal tract and the skin are the one organ. Remember, we are a donut.
Yeah.
It's the outside of your body, and the triggers that go on the gut play out in the skin. So 85% roughly of people who have infantile eczema have true food allergy. Of all the adults that get true food allergy, about the same proportion, 85%, had allergy as a child, had eczema as a child. So the general view is, if you see eczema on the skin, there may be value to some kind of superficial treatment, but the real treatment is, if they're breastfeeding, change the diet of the mum.
Yep.
If they're not breastfeeding, try a different milk. If they are eating new foods, kids get onto their first foods, and somewhere down the line, within, say, 6 weeks of starting foods, the skin is breaking out, then look to the change in diet. But a common line of treatment from both the allergists and the gastroenterologists is make sure there is living foods, that there are microbes in their food. Maintain the breastfeeding as long as possible to encourage that environment of a normal, successful bacterial growth in the gut.
Interestingly, from breast milk, nobody seems to speak about enzymes as well. Formula doesn't have enzymes. And I am pragmatic with regards to breastfeeding and feeding a baby. There are some women that just can't, and there are some women that choose not to. Okay. I would prefer, in my little arrogant thing, that at least try and express that first couple of weeks colostrum so that you're giving your baby an immune system that they haven't yet developed.
Yes.
But, hey, that's not my choice.
Hey, we're men. And I don't think we have all that many rights to say, what a woman should do. But what we can say, again, evolutionary side is, yes, birth was brutal. It was only 120 years ago that about 1/3 of children did not make it through to their second year of life. We've done a lot, basically in education, wealth training, and medical care to get babies through that. But along the way, we sacrificed a few things. Now, you can have more babies born. Evolution is a harsh teacher. Babies die in large numbers, and that's right the way through nature. It's not specific to humans.
No.
And evolutionary pressures are enormous. We wish to be anti-evolutionary. That's what medicine does. It's not survival of the strongest and most capable of filling the next generation. It's survival of those that are the weakest, those that are at most risk, go on to the next generation. Along the way, we developed caesarean section, brilliant for that mismatch between head and the pelvis and making babies and mothers live, but overused to bilio. Roughly we think about 11, maybe 12% of people should have a caesarean because of that mismatch or because of babies at risk. We're up to around about 50% or higher on the North Shore of Sydney. We are now encouraging mothers to do something which is grab a bit of the vaginal muck and use it as a swab and put it on the mouth of the baby. And now mothers are doing that. Why? You want to inoculate with whatever the mum's bugs are, and that's the starter culture. What feeds the starter culture is breast milk. And that first part of the breast milk, the colostrum, rich in immunoglobulins, rich in first protection. But the thing that differentiates human breast milk from all other mammals is the diversity of glycans. The range and diversity of glycans is nearly an order of magnitude higher than the next of the mammals around. We're similar, however, to the great ape. But that diversity is not there for no reason. It's the starter culture from the vagina plus feeding with those glycans. Breast milk also has exosomes, little bits of RNA wrapped up, just the mother's RNA, which seems to be mainly immunologically derived, delivered in tiny little packets, just nanometers across to get through the gut wall to genetically program their own babies. Babies give stem cells to mum through the pregnancy. We haven't been able to stop that yet. That's good for mums. That's where their arthritis, inflammation and things settle down. And mums give back the exosomes to say, hey, baby, I've developed an immune response out here. Here's the recipe. You can utilize this and you can keep yourself sane from the same diseases. So weirdly, we have a kind of immunization program at the genetic level going on between mother and baby. And when you go to cow's milk, there is nothing about cow's milk that knows what's going on in that human's environment. So,
we pasteurize it as well.
Yeah, that's right. The mismatches. That's right. The mismatches are the nutrient content, and the evolutionary side of that is if we can emulate at least what nature does, if we can at least give the mouthful of muck, if we can do the early part of breastfeeding, that's way, way better than just not paying any attention to it at all.
Mark, that would have to be the most eloquent description of the benefits of breastfeeding and vaginal birthing that I've ever heard of. The function of it. Brilliant.
Well, nature, in the end, is simple, but it's a complex way of getting there. And when human brains, my doctor training, we like to think of things as cause and effect. We are unaware of the web of evolutionary development. And so we think of it as, it's just nutrition from the milk. And there's not enough vitamin D and not enough iron in there, so we can do better by having fortified milk from another animal. And it shows the weakness of trying to second-guess evolution. It's not that evolution is perfect. It's simply that the Darwinian concept is it's the best that could have been done with those circumstances. And the survivors are those that have done the best in the circumstances. When you then go and change the world, you start cesarean sections. It was not a very common thing before this last century. When you change the nutrition to milk that the baby was never I won't say designed for, but the baby struggles to find full value from. When those things change, we take a risk in medicine by promoting those changes. And we've had to back off time after time. The breast milk, when I was going through medical school, we knew that it was insufficient to raise a healthy baby. You had to do this. Just recently, a baby born at 26 weeks, one of my patients, she persisted with the line, "I wish to breastfeed my baby." She was told by all the experts, "You cannot. It's impossible. The nutrient density is too low. We have to use these others." She fought them. She has a beautiful, healthy baby. And one paediatrician who has now changed his mind in Melbourne about whether a mother might be right in those circumstances. But the letters that came back early was, this baby may need to be separated from the crazy mother. Mothers aren't crazy. They've been raising babies ad infinitum. It's us that get crazy. We think we know better on how to raise a healthy child. And so that evolutionary process, respect it, acknowledge it. You may not go down that line in the medical or naturopathic or any other care. You may say, look, there is a cliff that you're going off that we have to stop. But at least acknowledging it makes us think, why is it there in the first place? Not just how do we override it. And I think that's my point there.
Getting back in a long, circuitous way
back to depression.
Depression. So look for inflammation, but the inflammation can be from a multitude of assaults. It can be dietary, it can be behaviour, sleep deprivation.
It could be chronic infections.
Could be chronic infections, could be emotion. So there's not just the physical or infectious worlds that cause that inflammation. We have
look to causes. So you and I have been through this. If you look to causes and you just put that extra thinking minute in, it isn't a big jump. It's just the ability of a doctor or a practitioner to say why. Even if you can't get the answer, keep the mind going on to the why. And the awareness for me and for other doctors that I know that inflammation triggers depression over and over gets us back to look for something that we would not otherwise have thought of. So depression is a marker of inflammation. Then we have a way of thinking about it, knowing that women have got a massive escalation of autoimmune disorders, thyroiditis, type 2 diabetes, polycystic ovarian syndrome. To know that they're there means that we go and look for them, and you often will find the enemies right there, that what the body's picking a fight with is not a bug, it's themselves. What triggers that is then your next question.
So for our listeners, I'm going to put up a couple of little tools, handy hints and tools, one of which is the etiological sieve, so that you can go through a list, if you like, of potential causes. And it was taught to me by a great doctor, Dr Edwin Nicol, who I cannot thank enough for him coming into my life many years ago.
And giving you a sieve.
And giving me a sieve. Let's move on to anxiety. Now,
I love this one.
Depression as an evolutionary thing, I have a hard time grasping. Anxiety, however, a heightened fear, I can see that as a protective response.
Yeah.
But then, of course, we're left with something once the noxious agent has been removed, once the danger signal has been removed.
Description. However, anxiety is bloody irritating. I have a very anxious partner. What's the upside? She knows the things that irritate her, and she takes those out of the environment, so I'm not irritated. So I can see a secondary evolutionary value of the things that are distressing for another person. Having someone who's got a high radar, a high alert to potential threat, has got one obvious evolutionary advantage. If you can smell moles and say, no, not that cave. If you can hear the growlings of lions or tigers or something in the distance and other people can't, if your sensory sensitivity is very high, then whatever that comes from, these days I think, a kind of post-traumatic emotional trauma of childhood is a very big player in those areas for setting the radar very high. But as far as communities went of, mobile communities where you shifted from area to area, having the sensitive individual, the ones on high alert the entire time, the ones that couldn't sleep deeply, had a great evolutionary advantage. You were not eaten the next morning because there was an awareness of something of a threat around. Not so great for the individual, but great for the group. And so in evolutionary terms, it's not always the survival of the individual. It's usually something benefits the ability to create the next generation. So creating the next generation is the close relatives of a person. Anxiety is one of those things which can get out of control very easily, and which has got high survival value. I see people who are chemically sensitive, noise sensitive, light sensitive, where everything impinges on them, but they are extremely capable of creating safe environments for themselves and their families. What's the upside of that? Well, probably that safe environment means that the toxins that most of us just put up with and were unaware of have an impact on their health, and they withdraw from it. Their withdrawal from it takes their family and their children away from those toxic insults. And the upside of that is you may have a mum or a dad who's extremely anxious, but at the very least you then have a safe physical environment, something where nutrition, food are appropriate for that person.
Now, we're talking here obviously about the canary in the mine shaft, and I was speaking recently with Dr Nicole Bilsma about this, about people, as you say, were heightened to smell noxious agents, and that might not be just the dangerous, the lion growling in the distance, but even things in our immediate environment like molds. You talk about anxiety, this heightened response, or forgive me, a heightened feeling, but then you have to respond to that. And there are basic three responses. There's the fright that you get. You can either fly from that, the flight response, or the fight response.
Yeah.
Talk to us about those as evolutionary medicine or advantages.
You're talking mainly there about the kind of autonomic adrenal type responses to a perceived threat. And so that perceived threat...
That was what I was after.
Yeah. The perceived threat goes on through our central nervous system and our sensory nervous system. So what is a threat? You look at a male sitting watching football in front of a couch, the only threat is lack of beer, right? That might be the threat response to them. But there are people who you and I would be able to nominate probably where an atom bomb would need to go off before there was any threat response whatsoever. They are so chill. There are other people for whom a bird tweeting 2 kilometres away will wake them up in the middle of the night with a startle response. The differences between those is where evolution plays its experiment. It has no particular interest in the individual, but an individual who is hyper-responsive has a survival value if there are threats around. That's preserved for a long period of time. And the flight, fright, and fight are the ways in which the body goes through a cycle, that if you can escape, the ability to flee something that is a threat is really, really useful. Can we suppress it? Yes. People work in terrible environments, go to school in terrible environments, and they put up with it, but they adapt to it at a cost. And often what's going on behind the scenes is the sensory nervous system is getting overloaded, screaming, saying, hey, get out of here. This is not the place. Mood and emotional changes go with that very, very directly. So males tend more onto the fight, I will attack, I will defend, and it may have a bit to do with testosterone in the brain. It certainly doesn't have to do with that when we're kids. But later on, that fight is a response which is not as common amongst females. The ability to flee, to be safe, to get away from a threat seems to be of high survival value. And so I think that we've overplayed it as just, it's flight, fright, fight. It is true, but those are playing out because there is a threat response.
Yeah.
We're paying big attention now to the trigeminal nerve. Why? Because the trigeminal nerve is the bad news nerve of the body. It's the blink response. It's the withdrawal. When people give smelling salts, to wake up boxers that have just been knocked out, it's not the olfactory nerve that's being hit with those. It's the trigeminal nerve endings at the very end, which is, holy hell, there is something terrifying here. And it really just plunges straight into an adrenal response and a heightened susceptibility to that adrenal response. So what people forget is the trigeminal nerve has got links that go right back to the spinal cord. It's got links right into the amygdala areas of the brain. And when a threat is perceived, whether that's through vision, the eye, as in the blink response, nose, mouth, bad taste, the very initial spitting out response of a poison is not related to the gustatory nerve. It is related simply to a trigeminal reflex response. So we are dealing now with a bad news nerve, which keeps finding threats that were not there all the way through history, but where there is an automatic response. The little branch that goes to the upper part of the brainstem very quickly activates the amygdala, and it activates the sensory system and puts the person on high alert. And now they're developing drugs for a lot of these kind of responses. You can use nasal sprays, for example, that stop some of the chemical sensitivities. Not by numbing down the nose, you can still smell it. It's just the trigeminal doesn't give the signal. The so-called threat response is extinguished. The same can be done in the mouth, that there are as a lot of exploration for what do we do to turn off the sensory signal. Now there you've got to think that extra step with evolutionary medicine. Is it a good idea just to turn off all our threat responses? If we could, if there was a magic pill that said, hey, everyone's going to be chill, there are no threats, then it's plausible that we could make the case there are no threats in the current world, so better that they're all turned off than left on. But then I think you would get away from that ability for the mother to decide on behalf of the baby, which food should I be eating? That instinctive response about protection of the most vulnerable amongst us would be lost as well. So the evolutionary value of high sensory inputs, my wife certainly went through this with her pregnancies, was all things that could be a threat to the baby are considered a threat to the mother. The escalation of that response is protective of a subsequent generation. You don't eat poisons. In the old days, poisons may be plants that could be, toxic to the baby. Now, there are a lot of the pesticides, perfumes, and other chemicals around paints and the like, and that response was never meant for paint or perfumes, but it has become adapted to that. What's not good news? The trigeminal nerve will tell you. And if we could switch the trigeminal nerve off, a lot of these sensory anxiety type responses could be extinguished. There's another approach to it, which is let's extinguish the amygdala response. The amygdala is this kind of the bad news little nucleus in the brain that takes account of all of the threats from the past and says, remember that, remember that, remember that. These are the bad news areas, and I think that that's where the action is with the post-traumatic stress disorders of childhood. When we're in those early stages and stresses are high, there's great evolutionary advantages to not running into those threats again later on. We're not in the old world where lions, tigers, and terrible mushrooms were coming to get us. We're in a different world.
Terrible mushrooms.
I use that word advisedly. But we're in a different world, but the threats are still picked up as threats, and they go into the programming of the brain to say, keep that in mind for the next occasion. And bodies do go through aversion responses, sometimes maladaptive. It can destroy a person's life. It can even lead to suicide. So I'm not advocating that we just leave it alone and act natural. I'm saying that the awareness of the why makes us ask about what was going on in childhood. Where did that evolutionary response get triggered? Many of the evolutionary responses we may not wish to have because the threats are gone. Now, what we have to do is try and adapt to those threat responses, find out more sensible ways of managing it, going back to causes.
We're talking about earlier getting rid of noxious elements and so that we can chill more. One of the functions that we need to have in our life is a decent amount of sleep. So what's the evolutionary medicine aspects of sleep, and what do and don't we know?
We are the least sleepers of all the primates, right? We have the lowest number of hours of sleep of all the primates and the highest absolute amount and relative amount of rapid eye movement sleep. There is something about humans when they became littler, big apes turning into little apes.
Yep.
There's something about mobility, getting to the ground, where we slept and how we had to sleep in order to be able to be bipeds, standing up, going and avoiding predators and the like. And so we've ended up with short sleep hours, which it seems like somewhere between 6 and around about 9 hours is typically okay. Not for kids. Kids tend to be longer and later. And the fact that schools start at 9 a.m. is an anti-evolutionary disaster. Getting kids up in the morning means putting them to bed early at night, and the natural sleep cycle of a child seems to be like 11 p.m. to around about 9 to 10 a.m. Anyway, go back from that. Sleep serves a purpose. And you're absolutely right. We don't even know what that purpose is. Garbage collection of the brain has been one of the processes that has been proposed. The other one is memory consolidation, that what's learned in the day gets a chance to percolate to the top and retain currency for the human. We sleep on the ground. or we tended to sleep on the ground, whereas apes go up into the trees. And so there is downsides to the ground, more parasites, more predators and the like. So something about the change in sleep to rapid eye movement sleep to a lower number of hours gives us more time to go and hunt for food, to avoid predators. And there seems to be an evolutionary cycle where there is wide variation from individual to individual. And the supposed purpose of that is that you have sentries on. We always had a shift work system that, being small, not very well protected omnivores on the ground, was never a great thing to be in a world that was a bit rugged. And so the sentry system means there's wide adaptability in our sleep cycle. That sleep cycle, again with evolution, having no interest in the individual, means some will sleep lightly, some will sleep deeply. Some will get maximum rest and be able to physically be very active in the morning. Some will be exhausted in the morning and will just potter on through the day with that sleep cycle. We want to have sleep as if it is a goal. What we need is restfulness that sleep provides. And the restfulness that sleep provides is often, in the evolutionary terms of today, not well managed by our lack of seasonality. We go into bedrooms, we switch off lights, we put on iPads or iPhones, blue lights disturbing the melatonin cycle and disturbing the sleep cycle. And so most of the things that we've done with sleep are of our own accord. It's that we don't sleep because we're tired, we sleep because the hours are meant to be sleep hours, and we're trying to impose that on an evolutionary cycle that might have meant some stay awake until midnight or 1 a.m. and sleep late, and there was no reason not to. We didn't get to work. There was no traffic. There was no such thing as a peak hour. So that natural variability within a population group has been constrained down to effectively 10 p.m. to around about 7 a.m. is the sleep period, and the only sleep period.
But in a tribe, hoping to survive the rough and rugged and dangerous environment, you would have had to have moved as a group to ward off predators. So there would have had to have been some aligning of rhythms, sleep, energy, activity rhythms.
And there always had to be somebody there to make sure that the attack didn't come at that time. If everyone's asleep at the same time, that's not a very good position to be in. So the variability of sleep within smallish groups of people has an evolutionary advantage. Does it have an advantage when you try and constrain the outliers to a standard method of sleep? Probably not. There are no predators around at the moment, and everybody tries to time their sleep according to a social cycle of work, school, getting up in the mornings. And for some people, that is an inappropriate cycle. I see that all the time. Our natural internal cycle is 25 hours, roughly. We align it with the sunlight, or we align it with dawn, or we align it with something to keep on resetting our cycle almost day to day. And in a world of artificial light, of iPhones, of blue light from a lot of screens around the place, that resetting of the clock every day is an incredibly difficult task for some people. There are no campfires anymore. It's not orange and red light.
No.
It is, when it gets dark, it gets light somewhere else, and we keep those lights on.
And if anybody wants to see just how light it is, look at the pictures from space of the world that are there. That just blew me away.
I know.
Like the bright lights, particularly when you see America and the huge cities around Europe.
We have no true nights.
No.
That's in fact absolutely true. And there are a lot of people, and I'm one of them, that in the middle of the day, in the middle of the night, it really doesn't matter. You put my head on a pillow, 30 seconds later, I am asleep. Oh. Would I wake up if a lion was attacking? I'd lose 1 or 2 legs before I even woke. And that's my type of sleep. My daughter has a different type. Each of my 3 daughters, have very different sleep types. And my wife will wake at any sound, any time through the night. Why would that be, and why do we all make it through? Because as a group, that probably served us somewhere in the past, but right at the moment, it makes it very difficult. And again, that threat response, that suggestion that a mother is always, until their children are grown up, has great evolutionary advantages. The babies will make it better if mum is oversensitive to threat rather than undersensitive to threat. Men, in evolutionary terms, are absolutely sacrificable after the last insemination that they did. In fact, it's preferable for them not to be there because they don't consume resources. And as my daughter said...
But they do protect.
They might, but younger men that are coming through protect even better. So I don't know that old 60-year-olds I'm not even going to go down that path. I'm not sure at what age we become useless, but I'm pretty sure it's before 60 in evolutionary terms. Mothers at age 50 still have children or can have children that are in their teenage years and need that protection. So again, the evolutionary narrative is males went out and killed things and got into risky situations, went to war in order to eliminate males, just as our X chromosome has been disintegrating over time. Yeah. That getting rid of males and having what's left over supporting the next generation is the job of evolution. It's not the job to be nice to anybody. We now have a lot of males around the place where there are no threats except the males themselves. And in many ways, that has distorted the whole societal kind of distribution of age and sex.
From an evolutionary perspective, and I guess part of this is cultural rather than evolutionary.
Well, they're the same thing. Right?
No.
The culture is still evolutionary.
Yeah, okay. So where I'm going with this, I'm just questioning my, males are the bigger muscle mass and therefore the protectors and the angry and the focus-driven and things like that. Men are from Mars, women are from Venus type aspects.
Which definitely is not right.
Okay, so that's what I'm questioning. Is from an evolutionary perspective, are you aware of any matriarchal societies where the women are the hunters, the women are the protectors?
In brutal evolutionary terms, women have to be the ones to breastfeed a child. No man in evolutionary terms, as far as I know, ever breastfed. Very few males, if any, ever gave birth to anything. Males have a different role at the origins of every next generation, and that is to provide one half of the genetic code. Their job seems to be as well that they are supportive in terms of when a mother has given birth and is most vulnerable, there's a protection level there, at least for that first period of life. I can imagine plenty of environments where the number of males could have been trivially low and women did all of the work. When it comes to food provision in terms of gardening and digging, women do the majority of that work. Men like to go and seems to be very active and aggressive and, play out their little games that men play out. But I think that the role differences are important. Evolution doesn't favour males' long-term survival. It favours human females' long-term survival. Why? Going way back, the head of a baby has to be big enough to fit out. Therefore, that baby's going to be dependent upon a mother for a good period of time. Many other animals drop their babies and can wander off, and evolution looks after what's left over. But that's not the case with humans. Every baby dies without a mother.
Just snipping off the issue of sleep and looking at what we would term a pathological condition, narcolepsy. Tell me a little bit, how the heck is that an evolutionary aspect of biology?
I found this fascinating, and looking at, what's our behaviours and what kind of things can we talk about in evolutionary biology, even obstructive sleep apnea we could come to. But narcolepsy is a fascinating example. It seems to be, as we understand it today, an autoimmune process affecting a very limited number of neurons that rapidly can put a person into a sleep-like state. It seems to also be a carryover from a time where one method of escaping predators, randomly distributed amongst the population, was to immediately drop to the ground and appear to be dead. And so,
which seems weird. Like I understand it happens with certain goats, and there's a couple of other animals that it happens with, but I don't get it for humans.
I believe that it happens with more animals than we think, because then the decision that's made by the predator is, what's more interesting, the thing lying on the ground or those other ones that are still running, getting away from me?
So that's the hunting response.
Yeah, that old joke of you don't have to be the fastest runner, you just have to be faster than your friend, faster than your friend. But the same thing applies, that when evolution plays its games, survival is defined sometimes unexpectedly. Neurons that suddenly make you drop to the ground, what the hell could that do? It just may allow, in a predator-prey situation, for a predator to lose interest in the thing that dropped down, think I can come back and get that later, and keep on pursuing the ones that are still running away. In any event, it is a conserved area of neurons from other animals that also do drop to the ground under extreme threat. The autoimmune side of this is, the evolutionary side first is, those neurons didn't select or deselect for anything, so they just stay there. There's no reason to not have them. There's no reason to have them once the big threats are gone. As they hang around, an autoimmune process which attacks the neurons, the axons and the myelin of them, makes these ones active again. So in thinking about an autoimmune disorder, the general rise in autoimmunity sees those things which are consequent upon it, and these neurons come back to life again and don't play out in threat situations. They play out randomly, almost at any time during a person's life. So what was maybe a million...
It very often is triggered by stress or
Yes.
excitability, though.
And as you would expect, that if you put the second factor in there, the vulnerability of those nerves to this action means that a minimal stress will have a big impact.
So we've spoken about the potential function of depression and even anxiety. Certainly sleep has a function. There is also this rhythmicity that if we look back from an evolutionary perspective, the clans of humans moving across the plains of Africa, there's two sides to it. There seems to be a need for rhythmicity to move as a group for protection, but then that diversity to have somebody awake on lookout. Can you talk to us about neurodiversity versus rhythmicity?
Okay. Nature has its rhythms irrespective of humans.
True.
We have rhythms of night and day. We have rhythms of seasons. We have rhythms all over the place. The fact that we have nature favouring diversity and survival in the most diverse of possible circumstances means that nature experiments relentlessly, that we are genetically programmed one way, but our SNPs and our expression of those genes and how the diet and sunlight and other things interact make the most valuable thing in nature and for humans in evolutionary development a diverse range of responses across a large number of people, or even a small number of people, even a tribe.
And diversity favours survivability, particularly in
survival
changing.
of somebody within that group.
Yeah.
So brutal nature will select. A really cold winter will find all those people who don't have the diabetic genes. Right? If you have genes to conserve your kilojoules, a brutal winter will see your tribe managing better than the lean ones that run around. Take it to the 21st century, you're going to be the ones getting the cardiac bypass grafts and you're going to be the ones seeing a lot of doctors about obesity. But as far as nature's concerned, it's irrelevant. What goes on in nature is diverse in the extreme, starvation up to sugars at vast amounts from fruits on trees. And so having a range of humans with different responses, with different neurological, sensory, metabolic responses, some of which will survive and some of which will not in the normal, monthly, yearly or otherwise distribution is of value. You're right, though. There is a second issue for tribes of people, and that is they need to get on together. They don't need to be killing each other, and so there is familial and there is genetic similarities which see that survival. We don't see that today in cities. You don't know who your relatives are. You don't know who your friends are. You're basically in little boxes stuck out there buying stuff from supermarkets. And a thing that I would say is evolution struggles with the rapid changes that go at a way higher than our evolutionary rate. If you think of, say, 10 generations as the minimum evolutionary time for selection, 10 generations is 250 years. We've changed an environment in 100 years to a level that no one could recognise from 100 years ago. Can evolution keep up with that? No. And so what steps in is the anti-evolutionary medicine. You are getting fat, you are getting sick, you are sleepless, you are depressed. Our answer to it is, we will give you this, that. We will give you something for, say, a hyperactivity disorder. We're very big on amphetamines these days. We are answering questions which are deeper questions by trivial answers. We are giving pills for modifying humans to fit a new environment without ever going back to the question of what in this person's environment could be changed to see the value of that, say, neurodiversity, that attention deficit. What will we do? We give those kids activities, high activity, something that exhausts them and that really keeps their attention intact. Don't put them into schools. Don't make them learn things sitting down for 8 hours of a day. That's constraining everybody into the same box. So the lifestyle medicine concept is pay attention to what the lifestyles that we had an evolutionary comfort with, the cycles of the season. Get the foods in season in place for every family. Get a time where sleeping is honoured, but where you do not force everybody into the same box of you awake at 7 in the morning. Allow for kids to have that neurodiversity. Some will be on the spectrum, some will be hyperactive, others will be absolute little darlings that go to sleep at the same time every night. But instead of constraining them and organising nature into boxes of what is the right outcome and using our pills that way, I think that we have to take a different approach in lifestyle medicine to how does sleep work? How do families work? How do we get communities back? How do we get foods in season that are reliably going to leave people on that cycle of summer, winter, autumn and spring? And those are powerful decisions that we have to make. We have a dead end with a medical approach to constraining everybody to a norm. Nature values diversity. Nature values a diverse range of responses, babies being made all the time that can respond to those diverse circumstances. And until we understand that, evolutionary medicine just sits on the side a little bit of, oh, here's an interesting fact you didn't know. Yeah. But if we doctors and practitioners say, here's how we're going to organise sleep, here's the diet that you need to start to focus on, and here's the diversity of the foods and environments you need to be in, here's why you exercise. What the hell? We thought exercise was just to make strong muscles. It signals the whole nervous system and organises a whole range of activities, male or female. And here's how you birth and feed and deliver. Those are powerful ways of stopping disease in its tracks. If we don't do it, we'll go on paying for disease and the survival of the weakest, and we'll keep on doing that. If we are smart enough and we change our environment, we provide an environment which allows for that diversity, and we honour it right through from childhood to birthing.
I both love and hate the way that you trigger, for every answer that you give me, you trigger 10, 20, 30 more questions.
Right.
I have some of those, but we have run out of time. A couple of things that I'm going to ask our
listeners.
We
cannot do part 4.
A couple of things I'm going to ask our listeners to give us some feedback on. What do you think about the rhythmicity that is experienced with, say, women living together with their periods, with menstruation? What function do you think that has? And here's another one for you. Do you think potentially that there's some reaction to maybe uncovering these nerves that you spoke about with narcolepsy? Do you think perhaps neurodiversity with behavioural disorders making the next generation of Einsteins, the ADHD, the autistic spectrum disorder type thinking, do you think that might have a function? And do you think what's going to happen is that they become so prevalent that we're going to have to change the way we educate our young? There you go. There's a few questions.
We are changing it. I will tell you one little thing. 6 years ago, I went to California to a developers conference, an app developers conference, 5,000 people, 4,500 at least of which you would describe as on the spectrum, probably really autistic. These are the gods of the new century. Yes. They make the apps, they make the constraints, they make the algorithms that we are starting to live by. So the idea that this kind of spectrum, highly focused on a task, cannot socialise, cannot manage the real life, the fact that they're creating the apps that allow us to so-called manage our real life, we've got to really think about that. It is their time. It's like John Howard in the past. Sometimes your time appears where what is considered a defect actually is the opening of a new gate for a whole new type of world.
Dr Mark Donohoe, thank you, so brilliantly said and wrapped up. I love what you bring to FX Medicine to just awaken us, awaken me to just new ways of thinking and new ways of helping people. Thank you so much for joining us on FX Medicine today.
Thank you. That's what neurodiversity will do.
This is FX Medicine. I'm Andrew Whitfield Cook. If you're loving our FX Medicine podcasts, please don't forget to share us with your colleagues, family and friends.